So good afternoon to everyone. Welcome back to another class. So in last week's Saturday's class, we looked at the last thing we looked at was the different types of secondary storage. And so basically we're finished with the hardware part of our um, fundamentals of hardware. So if we check our mind map, if we check our mind map, you'll notice that we've already looked at the central processing unit and its parts. We looked at the various input devices and the types of input devices. We looked at output devices and its types, hard copy, soft copy, and various examples of them. We looked at memory, the different types of memory, and we looked at storage last week. So we looked at storage, what are the types of storage, and what examples of those types we have. Quick question. Memory, is that primary storage or secondary storage? Does anyone remember? So under storage, we have two types. As you can see here, we have primary and we have secondary. Does anyone remember which one I said is memory? Which one is your RAM? Which one is your ROM? That one?
ROM is primary.
Right, that is correct. It is your primary memory. Any reason as to why? Do you remember the reason? What is the differentiating factor between primary and secondary storage?
Primary is used right away, I think.
Yeah, it's that is true about it. But we're looking for the main differentiation between primary and secondary. What makes them completely different? It's right here, the first paragraph. What's the differentiating factor between primary and secondary storage?
Primary is not really stored for long, but secondary can be stored for later use, I guess.
So when you want it for later use, you are going to use your secondary storage. So if you want your data to be stored permanently, that is going to be your secondary storage. But when the data is just temporary, like temporary in that the data is only there when you only have electricity, that is what we call primary memory. Alright, so today we're going to move on to chapter 1.6. We're going to look at system software. Are you guys hearing clearly or am I breaking up?
So hearing clear.
Alright, good, very good. So, we're starting system software. Remember once again, if I'm going too fast, going too slow, let me know. If you want to ask a question, you can stop me at any time. If you want further clarification, you can do so also. Make mention of that. Alright, so the first paragraph, system software is the name given to the software that controls hardware and all other software. So we learned about all the various hardware your computer has. If you look at this mind map, you'll see all of them. Your storage, your memory, your output devices, your input devices, your central processing unit, and all the various types and examples that fall under those categories. The system software controls all of those hardware and any other software. So any other software other than the system software. Because remember, we have the other type of software called application software. So the system software controls all of those hardware and any other software that is running on your computer. So we have two types of system software. We have your operating system, that's one, and we have utility software. Now there's actually another one called driver, but that's more technical. So we are just going to focus on these two that you're seeing here. One, operating system, two, utility software, but there's another called a driver. So if we go back to our mind map, we should be on the left hand side now. So we have software, we have our two types of software, system and application. And as I just mentioned, on the system, you're going to have operating system and utility software. Now I'm going to add in driver. I'm going to call it device driver. So that's a bit more clear. But remember, I said only these two we're going to focus on, operating system and utility. Are you guys following so far?
So,
Great. So we're going to look at the first type of system software, that is the operating system. Now, what is this operating system? Now, the operating system is most commonly the most commonly used system software is the operating system. So it's the most commonly used. So out of these two types, out of the operating system and utility, for the type of system software, let me look at the diagram. Out of these two here, operating system and utility, the operating system is what is mostly used. So that is why sometimes when persons are talking about the system software, they're mostly referring to the operating system, because this is the most dominant one. You can see it's the most used out of the two. So that's the first point there. The second point is that your system, without an operating system, your computer is not going to work. Whether it's a laptop, whether it's a desktop, whether it's your phone, whether it's your smartwatch, they all have a software called an operating system. And without that operating system, the device will not work. For example, and even if your phone is off, your computer is off, can any of you use your phone or your computer?
No, sir.
No, you cannot. Because every time you turn on your phone, every time you turn on your computer, an operating system is starting up. All of those devices have an operating system. And without it starting up, your device will not work. So, we have so that's the second point there. Now, we're going to look at some type of operating system. So, these examples here, Microsoft Windows 10, Apple Mac OS X, Linux, those are called the desktop-based operating system. Or we could also say they're just called operating system. For smaller devices now, we call it mobile operating system. So those are going to be Apple iOS, Google Android, and so on. So let's go to our diagram. So under operating system, we're going to call this desktop. operating system, but you can just simply call it operating system also. But we say desktop to basically differentiate it. Like how we say mobile operating system. So under the mobile now, we're going to go with desktop first. On the desktop, we're going to have Microsoft Windows. So we're going to use 11. And remember, all the variations are examples. All the variations. So even Microsoft Windows 10, Microsoft Windows 7, those are all examples. But to get other example, did I spell something incorrect? So we have Apple, Mac OS X, and we have Linux. Anybody remember the other one? Starts with U.
Unix.
Unix. Very good. So that's Unix. And under mobile, we're gonna have Apple iOS. We're gonna have Google Android and all its variations, just like how Microsoft has all its variations. Any other examples you guys can remember? We have Amazon Fire OS. We have Harmony OS. Even Google Chrome OS, that is a mobile operating system. So you have a few examples there of desktop-based operating system and mobile operating systems. Good. Are you guys clear on operating system?
Yes, sir.
Yes, sir.
Great. So we're gonna move on to booting. Now, booting is basically a term to indicate that your computer is starting up. But how does this computer start up now? Booting basically means your computer is starting up. Because you would normally say, use the word booting. A person would use it in a sentence, my computer is booting up, which indicates that their computer is starting. So the process of starting a computer is known as booting. So the first thing your computer does when you turn on that power button, when you press that power button, is that it checks that it is working properly. So it checks it is working properly by following certain instructions. So instructions will be held in a ROM chip called the BIOS. And I think I already taught this chapter already, and I gave a diagram like this here, that you have a motherboard, and on your motherboard is a BIOS. So this is your BIOS here. So this is the ROM chip, and then at the top here you're gonna have your RAM. So this is your RAM. Your CPU is gonna be over here. Your hard drive is gonna be here. Your power button is going to be somewhere here. So what's going to happen, let's go back to the paragraph. So it checks to make sure everything is working, and then it looks for an operating system. So it checks and makes sure everything is working. When everything is working, it looks for an operating system. And what does it do with that operating system? It loads that operating system into RAM. So if we can draw a diagram of that, it's going to be something like this here. So one, you press that power button and electricity flows to this ROM chip. And the instructions in the ROM chip is to check everyone and make sure they're okay. So it's going to send a signal to the RAM, are you okay? Send a signal to the CPU, are you okay? Send a signal to the hard drive, are you okay? And any other hardware. It's going to check and make sure everybody is okay. Now, when everything is okay, do any of you have a desktop-based computer? No one with a desktop? Have any of you heard when a computer starts up? Have any of you heard it made a beep sound?
Yes, sir.
Right. So that beep sound is indicating that the BIOS checked all the hardware and everything is okay. A single beep and your computer starts up means the BIOS checked everyone and everyone is okay. So now when everyone is okay, the BIOS now is going to look for a operating system. So your operating system on a normal situation is going to be on your hard drive. It could maybe be on a DVD, a flash drive, but in most cases, it's on your hard drive. So from this BIOS now, it's going to look for an operating system. So it's going to go to your hard drive and ask the hard drive, do you have an operating system? Yes, I have an operating system. How do you update your BIOS? Alright, I'll come back to that question when I finish talking about booting. So you go to the hard drive and you check for that operating system. The hard drive is going to say, yes, I have an operating system. So from the hard drive now, the operating system is going to go to your RAM and it gets loaded into your RAM. Because remember when we learned about memory, when we learned about RAM, everything has to be in RAM for your processor to process that data. So anything you're working on, anything your computer is running, it must be inside of RAM. So the operating system gets loaded into RAM, and that is how your computer starts up. So when you see Windows is starting, or even on your phone, you see the Samsung logo, you see the Apple logo, it basically means that your operating system is being loaded into RAM and your device is starting up. And then that data in RAM now is going to go back and forth between the CPU for the CPU to process it. Are you guys clear on what is booting?
Yes, sir.
Great. Now for Hafi's question. Your question is going to vary. So say for example, I'm going to show you an example. First, you have to know what device you have. So in my case, I have a where do I find it? Basically, you need to know what type of computer you have or what type of motherboard you have. So in my case, I have a Dell Inspiron. And so Dell Inspiron, what is it? 137000, and you just type in BIOS at the end of it. And it should take you to the developer website. And you basically follow the instructions here, and they tell you basically how to upgrade your BIOS. Now, your BIOS is not something you should play around with. If you don't know how to update it, if you don't know what you're basically doing, I wouldn't recommend doing it. Because if you notice, if you corrupt your BIOS, if you look at the booting process, if you corrupt this BIOS, so say we corrupt this BIOS here. I just corrupted this BIOS. I tried updating it and it did not update correctly. Do you think your computer is going to start up? What do you guys think?
No, sir. It won't start up properly.
No, it actually won't even start up. Not that it won't start up properly, it might not even start up because your BIOS is that important. Your BIOS is what looks for the operating system. Nothing else looks for it, only the BIOS. So that's how important the BIOS is. Alright, so we got some additional information there. Good, so we're gonna move on to some additional information about the operating system, what it basically does. How important is this operating system? Well, these are some functions of the operating system. The operating system carries out hardware control. Remember we talked about that in the definition. Your operating system or your system software controls the hardware. It also does software control. What else does it do? It does memory management. It does input-output management. It does process management. And it does file management. So these are all functions of the operating system. So let's see what is hardware control. Give me a second. Alright, so what is hardware control? The operating system supports tasks like input, transferring data between primary and secondary memory, display and output. So when you type on the keyboard, if you have a Word document open, what they're basically saying, you have a Word document open and you start typing on this keyboard, your operating system is directing all of that. When I typed on the keyboard, it collected that instruction, sent it to the processor, it processed it, and ensured that data came on the screen, it came on the monitor as an output. So it's controlling all of that hardware, everything that is being carried out, everything that data travels between the hardware devices. Continuing the paragraph, it also sets the rules for controlling hardware resources, such as peripheral devices. Remember, we learned about that term. Peripheral devices like mouse, keyboard, the amount of memory, CPU allocation, this space. What this means is that your operating system, which is doing hardware control, can control who gets to use the keyboard, who gets to use the mouse, who gets to use the memory, how much of the CPU can you use, when can you use it. Those are all functions of the operating system. Who can use the device, when they can use it, and basically how long, how much, and so on. That is basically hardware control. It's like if it's a police, basically controlling who can go in what direction, when, where, why, and so on. Are you guys following? No?
So what was the question?
I'm asking if you guys are following. What is hardware control?
Yes, sir.
Okay. So we're going to look at next what is software control. So how does it control the software part of your computer? So the operating system controls how all software applications, games, programs work on your computer. So I have Microsoft Edge open here. The operating system is controlling this application. It says what it can, what it cannot do. I have Paint open. The operating system is what is controlling it. So every application you have open, every program that you have open, whether it's a game, whether it's some software, application, program, whatever the case may be, your operating system is controlling how it works. So that there is software control. Next, we have memory management. What is memory management? Well, we already know that memory refers to RAM. So it's basically RAM management, memory management. Who can use the who can use the memory? How much of the memory can you use? And so on. So when a program or data is too large to fit into main memory, we use a method called virtual memory so that we can split the program and be able to manage it so that it can be used inside of RAM, can be used inside of memory. So the required blocks, they're swapped between main memory and secondary storage. So this is important to take note of. So let me draw a diagram of that. Let me save this here. Putin. Alright, so let me open a new file. What are we looking at? We're looking at memory management. So a same motherboard, I'm drawing a CPU, I'm drawing memory, but outside here, I'm drawing what it's going to look like. So say this is memory, and so this is your RAM, and we're gonna have we're gonna have your hard drive at the bottom here. So this is your hard drive. So this here, your hard drive, which is your secondary storage, is going to be your virtual memory. So what's gonna happen now? So let me take that off. Inside of this RAM is where all the applications are going to be stored. So say for instance Windows 10 is going to be here, Paint is going to be here, Word is going to be here. But notice we have a small amount of space remaining because we don't have a lot of RAM. So what the computer is going to do now is going to, say for instance we open a game. So and the game basically has to take so much space. So all of this is for the game. Now obviously it cannot fit. So what it's going to do is going to take one of these smaller programs here. So it might take Paint and put it in the hard drive. So Paint is going to go here now. It might take, I think this is Word. It might take Word and put it into the hard drive now. So Word is going to be here. So what is going to happen now, when those two are taken out, these two here are taken out, the space can now be used for the game. And they're being stored inside of the hard drive, the virtual memory. So the game now has the space in the RAM for you to play the game, but when you want to open Paint, what it's going to do now is going to take that game, take piece of the game, or maybe even the whole game, and put it inside of the virtual memory. So your game is going to go here now. And it's going to take that application now and put it back into RAM. So it's a constant swapping back and forth. This is what we call virtual memory. Why do we need to do this? Because your CPU, remember your CPU, which processes your data, and only process data that is inside of RAM. So everything has to be in RAM for your computer to work. And when your RAM is too small or does not have enough space, we use a method called virtual memory to try to make it a little more larger or to accommodate any additional programs that we have open. But it's not it's not magic. It doesn't make your computer work better. It actually can make your computer work slow and it actually doesn't work that effectively. So it doesn't mean you can have a bunch of applications open. So if at any point in time you notice that your computer is running a bit slow, one of the things you should check is how many applications do you have open. So all like how I have these 5 tabs here open. If I did not have enough RAM, I should not have so many tabs open. I should be closing a few of them. Because even though it's the same application, each tab I open is going to take up more memory in my computer. So that's why you're advised not to have too many tabs open on your computer. All right. Are you guys clear on memory management?
Yes, sir.
All right. Any questions from anyone? No questions? All right. So we're going to go on to input output management. So we know what is input, we know what is output. Input is getting data into your computer. Output is getting data out of your computer. So we're going to manage how data gets input, when, where, how we're going to manage when data gets output, when, where, how, and so on. So since each device has a program called a driver, oh, we actually have it here. Each device has a program called a driver. What does this driver do? It allows the device to communicate with the computer so that the flow of information among devices can be managed and coordinated. So basically, if you plug in your keyboard, you plug in your mouse, you plug in a webcam, what happens is that a driver is installed for that device. Think of the driver like a translator. Your let me save this also. Virtual memory. So this is your computer. I'm drawing a desktop. So this is a desktop here. This is not a desktop. This is the system unit. So say for example you have a keyboard. You have a keyboard, and you're gonna plug that keyboard into this computer here. Now, before it can get plugged in, you have to install what is called a driver. So the keyboard communicates to the computer through the driver, through that software, through that program. So the driver is like a translator. Think of it that way. Think of both of the devices speaking two different language, and this driver here allows them to communicate. So any and every device, even your CPU, your hard drive, they all have a software called a driver that allows them to communicate with the computer. Any of you ever saw that when you plugged in a printer or your flash drive, it says a driver was installed or not installed and so on? No one? Well, if in the future you see that when you plug in a device into your computer and it says driver not installed, or you wonder why the device that you just plugged in is not working, yeah, when it says new device was plugged in, it basically means that the driver was installed. I guess the new messages aren't that clear. So that's what it usually means, that it just installed the driver, so it's ready. So the tip I'm giving you guys, that in the future, if you see a message that device not installed, any of you ever saw that message, device not installed? No? Well, if you ever see it in the future, it basically means that the driver was not installed. So if the driver is not installed, it indicates that the device will not work. And that's the reason why it's not working. So you try to download the driver and install it to get the device working on your computer. So that is the part of the operating system. I'm trying to find my cursor. Yeah, that is the part of the operating system that controls input and output, your driver. So next we have process management. What is process management? What part of your computer does process? Anyone? What part of your computer processes?
The CPU.
The CPU. Very good. It's in the name. Central Processing Unit. So the CPU is what we are trying to manage here. So the process management allocates time for processes. Processes is also another word for programs. It allocates time for processes to use the CPU. So it checks on processes waiting to use the CPU and signals when the CPU is available. So driver. So this here is your CPU, and this here is your RAM. So in your RAM, you're gonna have Microsoft Word open. So here, it is called a process, whatever is inside of RAM. But if it was inside of your hard drive, so this is your hard drive here, and you have Microsoft Word, MS Word, inside of your hard drive, installed on your hard drive, here we call it a program or a software or application, however you want to term it. But once it goes into your RAM, we call it a process. So process management is where we control and say who gets to use the CPU, when, for how long, and so on. Are you guys following so far?
Yes, sir.
Great. So the last management for your operating system is file management. File management is basically when you guys are moving files on your computer. When you copy a file, when you delete a file, you cut a file, you rename a file, anything that deals with files on your computer, that is under file management. So when you save something, copy, rename, delete, those are all parts of file management. Your operating system checks to ensure that you can save it properly, you can copy it, you can rename it, you can delete it, and so on. How does it do that? Well, it checks the memory, ensure it has enough space to do everything, and so on. So, any of you ever try to transfer a file to your flash drive, and a message came up and say, file too large, or your device does not have enough space?
Yes, sir.
Right. That is an example of file management. Before you transfer the file, what the operating system is going to do is going to check your device, check your flash drive. How much space does it have? 500 megabytes free. It's going to check the file. What is the size of the file? 600 megabytes. So it's going to automatically see the file is too large, and it's going to give you a message that the device does not have enough space. That there is an example of file management. Good. So those are all the functions of the operating system. And the last system software is your utility software. Utility, anyone has a definition for utility? or know what the term utility means? So we have a definition here. So the state of being useful, profitable, or beneficial. So we're going to focus on being useful and beneficial. So this utility software, it is useful and beneficial to the operating system, to the system software. Why? What does it do? Well, it is a specialized software that tries to protect and maintain the system software. So that is why it is useful. That is why it is beneficial. What are some examples of protecting and maintaining? Well, it protects against computer viruses. Before you can accidentally delete a file, it will back up that file. If you accidentally delete it, it can help you to recover files and so on. So these are some examples as to how your utility software protects and maintains the system software. Protects you against viruses, backs up your file, recovers your file, and so on. Good. Are you guys clear in the entire chapter? Anyone? Any questions? So Hafi's question, how to know how old is your CPU and how to get specific information on our components. So if you want to know about your CPU, firstly you have to know what CPU do you have. So you're going to go to start, you're going to go to settings, system, about, because you basically wanted to know what is the name of your CPU. So for example, my CPU's name, so right next to processor, AMD Ryzen 7 2700U. So I'm going to copy that, go to my browser, and I'm going to search for that. And a website with information or specification, or at the very end you can type in specs or specification, and it's going to give you the information that you basically need. So the information, any one of these websites are going to work, and it's going to give you all of the necessary information for that CPU. So AMD Ryzen 7 and all the information about it. It was launched in 2017 and so on. Any other questions? Alright, do you guys want us to do this chapter here or you want us to stop here? You guys need to let me know if you can go more. So you guys aren't responding. I don't know if you're there or not.
Sir, whichever choice you think is best, you choose.
I think we should do this here because at the rate we're going, we mightn't finish all of the content. So at least let me finish off this chapter here. That's good with you?
Yes, sir.
Alright, so let's try to finish off this chapter and that'll be it for the day. So, any of you wondered why we have the two types of software here? We have 1.6 for system software, but we know the other type of software is application. But that's still a chapter 1.8. Why do we have this random chapter in the middle? Anybody wonder that question? Wondered about that? Or you didn't give it much thought?
Didn't give it much thought.
All right. Well, I was actually wondering about it a few minutes ago, and then I realized why this chapter is right after the system software is because these types of data processing inside of this chapter here that we're going to learn about is actually how your operating system functions when it comes to processing data. So there are different methods of processing data, and it is your operating system that basically directs the processing of data. Remember, we learned about that. Your operating system is directing all of these things here: hardware control, software control, the memory, the input, the process. It's directing all of that. So, what are the methods now of directing all of that? The methods are batch processing, time sharing, and online and real-time processing. Those are our methods there. So let's get into it. So data must be processed by the most suitable means. It can then be transferred to one or more computer systems for more processing, for output, or for storage. What they're basically saying is that you need the most suitable method of processing data. Not all data are you going to process it the same way. Each data is going to require maybe a different way of processing it. So the first method is called batch processing. So what is batch processing? It is a system is one where data is collected together in a batch before processing starts. So as the name batch indicates, it collects the data in a batch and then processes the data. So batch processing is suitable for tasks when you have a large amount of data. So if you're going to be collecting a large amount of data on a regular basis, it's going to be more suitable to use batch processing. Now think about this example, your utility bills, GPL, the internet bill, and so on. Do you guys get your GPL bill, your internet bill? Do you get it daily or monthly?
Monthly.
Monthly.
Which do you think is more practical? To get it daily or to get it monthly?
Monthly.
Right. Won't you find it annoying that every day you're gonna be getting a bill?
Yeah, it would.
Yeah, that every day you get a bill. I use the internet for $500 today. Tomorrow I use it for 600. The next day maybe 400. It's gonna be a little annoying. But because that information, that data, it's a regular thing. It's something that is going to be collected daily. It's a guarantee that you're going to be collecting it daily. The more suitable method is going to be to collect it into a batch and then process that data. So batch processing, you can collect it two ways. You can collect it based on time, or you can collect it based on amount. So for example, when it comes to time, you can say monthly. Every month, I'm going to collect this information, this data, and at the end of the month, I'm going to process it. So throughout the month, I'm going to collect all of this data, and when I reach the end, I'm going to process it and carry out whatever action I need. Or you can set an amount. Say maybe when the bill reaches 10,000, then process the information. When it reaches the 10,000, every time it reaches 10,000, processes it at that stage. So you're still collecting the data, but you're collecting it up to a certain point and then process it. So continuing the paragraph. So when a batch job begins, it's going to continue until it is either completed or you get an error. So it's going to continue collecting data until something causes an error while collecting, or until it finishes collecting and processing. That is when it's going to finish. So some examples of batch processing is going to include your utility bill, water, electricity, payroll system. Persons don't get paid daily. We get paid monthly. So they're going to calculate how much we're going to get paid over this monthly period, and they pay us that 1 monthly salary. Your examination card. You don't get a report weekly or monthly. You get a report based on a term. So that is another example of collecting all of that data into a batch and then process it. Your credit card. For those who, your parents that have a card that they can make online purchases or carry out transaction, when Republic Bank or any one of the bank sends out a bank statement about what transactions you made, it's not a daily bank statement. It's a monthly, and some of them aren't even monthly. Some of them are maybe 2 months interval, 3 months interval. So they're collecting all of that data for that period and then process it. Continuing the paragraph. The customer does not receive a bill for each separate credit card purchase, but one monthly bill. So the bill is created through a batch processing system where all the data is collected, held onto the bill, held until the bill is processed as a batch at the end of the billing cycle. So the basic thing to remember, batch processing collects the data and it waits on a specific time or amount, and then processes that data. What is the advantage? The advantage is that once the data is submitted for processing, the computer can be left running without human interaction. So you can just leave the computer, have it collecting all of the data, and you don't need to do anything. It's just going to collect data all the time. Now, while the computer is collecting this data, it's not doing anything major. So you can schedule other jobs. You can basically put it to do other things while it is collecting that data. So that's your two advantage there. Your disadvantage is that there's a delay before you can process that data. Obviously, you gotta wait before you can get that process information. Some persons may not like waiting, and then some persons may need the information before that period of time, but they have to wait on the batch system. So that is batch processing, and that is the advantage and disadvantage there. Are you guys following?
Yes, sir.
Yes, sir.
Great. So the next type of processing is time sharing. Time sharing is basically as the name indicates. You are sharing time. What is sharing time? A single computer, you are sharing the time of a single computer. So the paragraph states, a time sharing system allows many users to share the time of a single computer. So each user is given a slice of the CPU by the computer. So say for example, this is the CPU here. So this is the CPU. So we can say Hafiz can use that part there. Erica can use that part. Leroy can use that part. Samir can use that part. So they divide up the CPU so that other persons, many persons can make use of it. So the computer works so fast that each user thinks that they are the only person using this computer basically. So one example of time sharing is, for example, a bank system, which allows hundreds of people to access the same program on the mainframe at the same time. So that at the bank, they're using basically one software on a computer called a mainframe, and it's one software being run on that mainframe, but many persons, like this diagram here, that it seems as though it is different system, but it's the same system, the same mainframe running the same program. So other operating system control include multitasking. I'm sure you guys heard of this term already, multitasking. Multitasking is allowing more than one program to run at the same time. So more than one program at the same time. So like how I have so many programs open at the bottom here, that is called multitasking. Multiprocessing is when you can executing programs using two or more processors. So you are executing programs with two or more processors. What we mean by processor, we mean CPU. So if your system has two or more CPU, you are carrying out multi-processing. We have multiprogramming, which executes two or more programs at the same time with only one processor. So two or more programs with one processor, that is multiprogramming. And multiprocessing is programs being run, the same two or more programs, but it's being run on two or more processor. So multiprocessing, the processing part is the multiple, and the program part here is the multiple part with only one processor. Multi-user allows more than one user on a computer. So multi-user, more than one user on a computer network to access the same file at the same time. So the word multi basically meaning many, more than one, and the word after it indicates many of what. So multitasking, tasking means basically doing something. So you can do more than one of something, basically run more than one program. Multiprocessing, you have more than one processor. Multiprogramming, you can run more than one program, but on only one processor. And multi-user is when you have multiple users on the same system. Are you guys following?
Yes, sir.
All right. So the last two types of processing is online and real time. So it's just as the name indicates, if something is online, it means it is basically on, it is turned on. So computers and peripheral devices are online when they are either connected to a main processor and turned on so that the operator can interact with them. So once the device is connected and it is turned on, it is called online. So for example, a printer is online. So when they're ready to print something, when you send a document to print to your printer and it prints that document, your printer was basically online to print that document. Now most printers have an online button you would press to turn on the machine. So basically an on button. So if it is off, we say it is offline. You can also be online if you're connected, say, to the internet through a modem or a network. So you can be online when you're connected to the internet. So online basically means something is on. Offline means it is off. Now, what is real time? A real time processing system processes data without delay. It is the opposite of batch processing. Remember, batch processing, you wait for a specific time, you wait for a specific amount. But real time does not wait on anything. There is no delay with real time. So, since a processing system must be connected to one or more computers to process data, it must be online. So, since there is no delay, since it's going to be processing the data all the time, then basically the device is going to be online all the time. So this was about a question in one of your quiz, whether a device can be online and real time at the same time. So basically, if a device is real time, meaning it is processing all the time, then it has to be online at the same time. You guys get that? Think you understand that?
Yes, sir.
So, in order for something to be real time, to be processing all the time, it has to be online. It basically has to be on all the time. Now, a device that is online does not mean it is real time. It does not mean that, because the device could be on, but it does not process right away. It could be some time before it processes. So, like for example, that batch system, the computer that is collecting the data, it's online all the time. It's collecting the data all the time, but it is not processing the data right away. So it's online, but it's not real time. But a system that is real time has to be online. So that is the differentiating factor there between the two. So what are some examples of real time? So the last line here says some examples are like your airplane landing system, electronic funds. So we talked about your utility bill. We say that it's more suitable to have that as batch, because it's going to be annoying to have your bill appearing every day. Now think about this here. If you go to ATM, should you wait and you say you want 10,000 from the ATM? Should you have to wait for a specific time or at the end of the month to collect this money? When would you want this money?
Immediately.
Right, immediately. You want it right away. So, we can clearly see that the batch system for ATM machine is not going to be suitable because you want your money right away. So, systems whereby you want your data right away needs to be real-time processing. But if there is no hurry for the data, you don't need it right away, you can wait for it within a month or 2 weeks and so on, then it's suitable to use the batch system. So what is the advantage? There's no delay and your information is always up to date because it's always processing that data. But what is the disadvantage now? The disadvantage is that the computer is going to be processing all the time. So it can only focus on this one task all the time. It can't be used for anything else. And as we talked about, it has to be online all the time. So like for example, all of you use social media. You use WhatsApp, you use Facebook, Instagram, and so on. I'm sure you guys knew about the other day when Facebook, WhatsApp, all of them went down. You guys remember that? And nobody could use them?
Yes, sir.
Good. So all of those systems, WhatsApp, Facebook, Instagram, they were all running on a computer. Now, because that computer went offline, no one could have used the service. So that's how we can see this disadvantage here. The computer has to be online all the time for you to use that service. And as soon as the Facebook server went down, WhatsApp server went down, no one could have used the service because the device was offline. Good. Are you guys clear on the different processing? We're gonna pause here for today. Next week we're gonna start with data transfer. Any questions?
I have a question, sir.
Go ahead.
So I'm not sure if this is related to the topic, but when the three apps went down, they were running by one computer, right?
No, because when companies are running a service, like for example a social media service, it's never run on a single computer because you don't want a situation like what happened there, whereby if the computer goes down, then the service goes down completely. So no company runs their service on one single computer. What they're gonna have is a computer called a server. This is actually the chapter we were looking at this week. A server. And what they're gonna do, they're gonna have multiple of that server. Let me get the actual picture for you guys. So Google server. We can actually look at my Facebook server room. So this here, let me download it so you guys can see it bigger. Yeah, so this here is Facebook's server room. Each of these tall black boxes that you're seeing has computers inside of it. They don't look like regular computers, but they're computers inside of it that we call a server. And each of these black box has multiple servers inside of it. It's not one server inside. Multiple servers are inside here. So if let me see if I can see inside of one of them.
No, but sir, but this is my question, right? I've heard that they got moved to another company. Would that still apply to them, or would they have to like do some processing?
No, that's what I'm trying to explain. That you have multiple computers here, basically multiple computer. So the service, say for example the Facebook service, it's on each one of these computers. So if this server went down, then all the other computers are still working. If this one went down, then all the rest are going to still be working. If that one went down, all the rest are going to be still working. Now, going to your question about moving to India or what country you said. Now, in addition to having a room filled with many servers inside of it, they will not have a single location. So I'm not sure if we're gonna get this information. How many server location does Facebook have? They're gonna have multiple locations, not just one location. So 18 different location Facebook has. Let me see if we're gonna get some of it. So it's not just one location, and this is for a company. So they don't just have one location, and in that one location, they don't just have one computer. So these are some of their locations here. So even if this one location at the top left went down, all these rest that you're seeing, the other circles, can still run the service. And even if one computer, like you see here, went down in a single place, in a single center, the others can still work and carry out the service. So going back to your question, it's not one computer that's running everything. And even if they moved, even if one location was moving, say for example one of these locations, it couldn't have affected other locations. Like how you're seeing there's many other locations. Did that answer your question?
Yes, sir.
All right. Any other questions? So we can see all of their locations here. Yeah, so that's how companies actually run their services. They have multiple different locations. So if one goes up in flame, this is actually something we're going to learn about. Is this term or next term? How companies set up their network and how they have different locations. All companies, they have different locations so that if one goes up in flame, basically, the other location, can continue to run the service. And even in the one location, they have multiple computers. If one computer damage, the other computer can take over. All right, to summarize what we looked at today, I want to see inside one of the server. All right. Okay, so this here is one server here that you see in here. So notice how thin it is, how flat it is. So this now is going to slide into what you're basically seeing here. So these are even thinner ones. So this is a thicker one that you're seeing. These thinner ones, we call them a blade server. So if I search for a blade server, so look, he's installing one of them here. So what he's holding here is one computer. So, and it's more powerful than the computer that you have right now. So the desktop that you're using right now, the laptop that you're using, what he's holding in his hand is more powerful than your computer. And notice this server has multiple of it inside. So if what he has in his hand damages, we look at the very top, there's 1, 2, 3, 4, 5, 6, 7, 8. 8 at the top here, ready to continue doing the work. What if he breaks on? What if he breaks one? Well, that's between him and the company. But what if he does break one, if he does damage one, how the system is set up is that the other computers are going to take over right away. They're constantly looking at the other computers, the other servers, to see if they are working or not. It's like they're checking on each other. Are you working all the time? And if one goes bad, they take over what that one was actually doing. So that's why there are so many of them. So we call them backup systems. So this is a backup of in case one of them goes bad. Any other questions?
No, sir.
All right. Well, to summarize what we looked at today we looked at the system software. Remember, there are two types. I don't think I continued my diagram. I'm going to try to see whatever else I need to add in. So remember, there are two types of system software we looked at today. We looked at the operating system and utility, and remember I spoke about the device driver. So remember, driver allows communication between the computer and device. Utility software basically supports the system software, and the operating system is what runs the entire computer. And we have some examples here. So you have to remember what is booting and what are the different functions of the operating system and how it processes data. What is batch processing, time sharing, online, and real time. Alright, if you guys don't have any questions, we shall end here for today. Enjoy your weekend.
Bye, sir.
Goodbye.